Okay, so I'm going to do a problem that is in your note, so please make sure you have that right in front of you so that you can follow along. The function that I'm considering is g of x equals 3x squared plus 4x minus 1, and I have that sketched out here. And this is what I'm trying to find. I like to find the exact area that's trapped between this function, 3x squared plus 4x minus 1, what I just told you, the x-axis, x equals a, and x equals b. All right, so specifically x equals 2 and x equals 5. Now your calculator will find that, because if you're looking for the exact area, you want an infinite number of rectangles, and that is your antiderivative. So let me show you the antiderivative that matches this set of criteria. Okay, please commit the criteria to memory. Your function, the x-axis, x equals a, and x equals b. All right, so here is your antiderivative. So I'm just going to go in my calculator and sketch that out. All right, so if you see y equals, you can see that I do have 3x squared plus 4x minus 1. If I hit graph, I do have that. I'm going to do second calc, and I'll go to number 7, just as we did in the previous video. My lower limit, so the lower of the two numbers that I'm going to use, is 2. And my upper limit is 5. Now I want my calculator to put an infinite number of rectangles between x equals 2 and x equals 5. And there we go. All right, so in order to really get a sense of what's occurring, I need to make my window bigger. So let me do that really quickly. The y's need to be more than 10. Why don't we do, I don't know, 50? That should be sufficient. Let's graph that, see what happens. Second calc, number 7, lower limit 2, upper limit 5. There we go. So you can see it better, but I would be able to see even more of that if I would have, let's make this 10, and then I'm going to go up to 200. Graph. Okay. So this is unnecessary if you're doing a calculation. However, I want you guys to see the region itself. There we go. All right. So what do I mean by it's trapped between the function and the x-axis? Okay, so if you'll notice, that's the first two set of criteria. That's your first pinch. So this means that I should be able to take my function and the x-axis and pinch it together, and my region should pop up. Again, pinch your function and your x-axis, and you'll notice my second pinch, there it is, says I need to start at x equals 2, I need to end at x equals 5. Here's the second pinch. Bam. Right? You're pinching your x values and you're pinching your x-axis and your function together. Right? So that's what you should always get when you take an antiderivative. Remember, your antiderivative is add your height times the base. So you're adding up the areas of rectangles. Now our goal is, give me one second because I need to acknowledge that this is 156 units of area according to what my calculator finds. So here at the very end of this I can put equals 156 units of area. All right, I'm not being very specific right now. I will be in the near future. Okay. So that's fine. The calculator is much more advanced than we are in the sense that it can throw an infinite number of rectangles in and find the area fairly rapidly. Let me sketch out that region here so that you're not confused. This is x equals 2. You go all the way to x equals 5. And let me show you again my pinch. I should be able to pinch the x-axis and my function wherever it is, whether my function is above the x-axis or below it. And then I should also be able to pinch between 2 and 5. So that's the region that we're describing. And this is what is 156 units of area. Okay? Now, according to a process called the fundamental theorem of calculus, we should be able to find this by hand. That's all the fundamental theorem of calculus is finding it by hand. So let me write down what I'm saying. We're using a process using a theory called the fundamental theorem of calculus. All right, so if I were to do this by hand, there are some steps. The very first step would be to acknowledge we know how to find this antiderivative, right? We know how to do this because this is just a power function, right? So the very first thing that you're going to do is you're going to take the antiderivative. Let's get to it. All right, so I'm going to rewrite what we have up there. The integral from 2 to 5 of 3x squared plus 4x minus 1 dx. This equals, all right, add 1 to the power. Notice this is what you did in your homework earlier. Divide by the new power, like that, plus 4x to the second power over 2 minus, notice there is an invisible x to the 0 right next to the 1. I'm going to zoom in so that you can see it. Okay, because x to the 0 is 1, so this becomes x to the first over 1 plus c. Okay, so there is your antiderivative. All right, so after you've done that, you have to acknowledge I didn't do anything with the 2, I didn't do anything with the 5. That's fine. Placeholder 2 and then 5. Right? So let me simplify this. This equals x cubed plus 2x squared minus x plus c, placeholder 2 to 5. All right, so the very next step, or step 2, is to plug the bigger number into your antiderivative. Hold on one second. And then you're going to subtract the smaller number into the antiderivative. Okay, I'm going to show you. All right, so what do I mean by plugging the bigger number into my antiderivative? Well, here's my antiderivative right there, and there is a fancy notation for that. I'll get to that in a minute. So I'm going to plug 5 in here. So let's see. 5 cubed plus 2 times 5 squared minus 5 plus c. And I'll subtract off what happens when we plug the 2 into your antiderivative. 2 cubed plus 2 times 2 squared minus 2 plus c. All right. Okay, so let's get ready to do some math. More like arithmetic, if you will. All right, 5 cubed is 125, plus 2 times 5 squared is 50, minus 5 plus c. Make sure you're looking at my math. I am human, I do err. Okay, so let's see, 125 plus 50 is 175, minus 5 gives me 170 plus c. Give me 1 second, I'll scoot that down. This should be a 2. Please correct that. So 8 plus 8 is 16, minus 2 is 14. Like that. All right, so now I'm going to distribute this negative. 170 plus c minus 14 minus c equals, well, the c's cancel, plus c minus c, and I get 156. All right, so that's some pretty good math, because you'll notice up here, where is it? Right there. I got the same answer. That's what the calculator got. Again, this process is called the fundamental theorem of calculus.